Assalamu alaikum dear students. This is our next problem. Problem having been once again chosen from the same book, Modern Physics by Kenneth S. Crane. As usual, we first come to its statement, then we will go to helping tools, and finally we will go to solution of this problem. Okay. Statement of this problem is bond strengths are frequently given in units of kilojoules per mole. Bond strengths are frequently given in units of kilojoules per mole. Find the molecular dissociation in electron volt from the following bond strengths. Part A, sodium chloride NaCl 410 kilojoule per mole. Part B, lithium Li2 106 kilojoule per mole. Part 3, nitrogen 945 kilojoule per mole. Dear students, here three parts are to be solved. Okay. In this problem, we have just to apply conversion factors. Okay, nothing else. What I have said, and I have said we have to do nothing except applying conversion factors. We know that tables of conversion factors are spread all over the book of physics, whether it is general physics book or modern physics book, etc. Okay, so conversion factors are spread throughout the book, and most probably and usually such tables occur in appendix at the end of each book. Okay. So, for the purpose of solving this problem, we have to find out those conversion factors which are applicable to this problem, and then we will reach our solution. Okay. No other definition or expression is involved except conversion factors. So those conversion factors will be included in helping tools. Okay, and then when we will come towards the solution of this problem, then we will find that there is nothing in the solution except application of conversion factors. First tool number 1, helping tools, tool number 1, Avogadro's number. Dear students, we are dealing with this number since about middle 8th class. Okay, or if not 8th, then definitely in 9th class this term is compulsorily included in the book. Okay, anyhow, Avogadro's number. 1 mole of a substance contains Na, that is the Avogadro's number, elementary units, usually atoms or molecules, where Na is found experimentally to be Na, where A is written as a subscript of N equal to 6.02 into 10 to power 23 per mole, mole inverse mole raised to power minus 1 within bracket Avogadro's number. Okay, this is the definition of Avogadro's number. Above is the definition in words and below is definition in mathematical expression. Okay, now we are going to its alternate version. Okay, Avogadro's number Na, where A is written as a subscript of N, is equal to 6.02 into 10 to power 23 is the number of atoms or molecules in 1 mole of any pure substance. Now we are moving to next alternate version of this tool. Okay, Na equal to 6.02 into 10 to power 3 within bracket molecules per mole. Now next version of this tool, Na equal to 6.02214129 within bracket it is written 27. It means after decimal we can expand this expression up to 27 digits, but only first 2 digits, that is 6.02, is quite enough. Okay, Avogadro's number Na is equal to 6.02214129 into 10 to power 23 molecules per mole within bracket Avogadro's number. This is the definition of Avogadro's number. Now tool number 2. 1 mole of a material, Avogadro's number Na equal to 6.022 into 10 to power 23 atoms. Here, dear students, it is important to point out here that this is not 6.022 point 10 to power 23. Okay, here dot is used in place of sign of multiplication. Okay, sometimes we use dot as a sign of multiplication, sometimes we use cross as a sign of multiplication, sometimes we use star as a sign of multiplication, and sometimes we do not use any sign or symbol and just write the other figure within bracket. Okay, so these are various modes of expressing sign of multiplication. Okay, 1 mole of a material has Avogadro's number Na equal to 6.022 into 10 to power 23 atoms or molecules. The mass of 1 mole of a material in grams is given by the sum of the atomic mass number of the atoms that make up the material. Okay. This tool deals with mole. First tool was dealing with Avogadro's number, and we know that Avogadro's number and mole are two indistinguishable or inseparable concepts. Okay. Anyhow, now we move to tool number 3. This is about the conversion factors of regarding energy. Here, dear students, 1, 2, 3, 4, 5, 6. 6 rows are included, and our concerned row is row number 5. Okay, that is 1 electron volt is equal to 1.602 into 10 to power minus 19 joule. This conversion factor will be used in this problem, and this conversion factor will not be used in this way. Okay, rather it will be used in this way that 1 joule will be equal to 1 divided by 1.602 into 10 to power plus 19. Okay, if we write 10 to power 19 in a numerator, then it will be written as a plus. If we write this 10 to power minus 19 in the denominator, then it will be minus 19. Okay, so we will use the value of 1 joule. Okay, 1 joule will remain here, and this factor will be shifted on other side of equality, and this factor will be divided on other side. Okay, it will become below this 1 joule will be equal to 1 over this factor, electron volt. Okay, next is the alternate version of above, and here again this thing is used, 1 2 3 4 5. Here total 5 rows are involved, and 4th row is our concerned conversion factor. Then another version of this helping tool, 1 2 3 4 5. Here again, out of 5 rows, 4th row is our concerned conversion factor. Okay, now we come towards its solution. First we will deal with the solution of part A. Okay, part A. In part A, E is given as 410 kilojoule per mole. We know that kilo is equal to 10 to power 3 or 1000. So if we remove this k, then we will have to increase 3 zeros with 410. Okay, that is, it will become 410 into 000. Okay, 410,000 joule per mole. In place of k, this figure has been transformed into this shape. Okay, then this figure is same, and in place of joule, we have used its value, which we had discussed a little earlier, that 1 electron volt is equal to so many joule, and from that expression we will calculate the value of 1 joule by shifting other factor on other side of the equality, and that factor will be divided after being shifted to other side of the equality. Okay, so in place of joule we have used this thing, and in place of mole we have used this alternate expression. Okay, as I had said earlier, as I had said in the beginning of this problem, that this problem is nothing but just a use of conversion factors. Okay, so what we have done, first we have used conversion factor of kilo K, then we have used conversion factor of joule J, then we have used conversion factor of mole. Okay, so far we have used 3 conversion factors, and then we will just simplify this. Okay, when we will simplify this, we will get this, and when we will further simplify it, we will get this, and then when we will further simplify it, we will get this. Okay, and this is the solution of our part A. Okay, I think it is clear, and it is better that we should move forward. Okay, yes. Part B, same steps will be repeated, nothing new. What we are going to do, we are going to use 3 conversion factors. First conversion factor of kilo K, second conversion factor of joule J, third conversion factor of mole. Okay, and then there is only simplification, nothing else. After simplification, E becomes equal to this 1.0996 electron volt per molecule. Okay, similarly part C, 945 kilojoule per mole. Here again, once again we will apply the same methodology, and we will apply 3 conversion factors. one conversion factor of K kilo, second conversion factor of joule J, and third conversion factor of mole. Okay, after applying these three conversion factors, we will just simplify the expression and we will reach this result 9.80 electron volt per molecule. And this is the end of our problem. This is the end of our video. Till next video, Allah Hafiz.